Welcome to our step-by-step guide on solving the majority element problem. In this video, we'll explore 3 different algorithms and walk you through each one in detail. First, read the question. So our question says we have given an array nums of size n, and we have to return the majority element. And the majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So we have to write a function to find an element in the array that is coming at least half times. There are 3 approaches for solving this question. The first one is we simply sort the array and return the middle element. The second one is we store all elements with their frequency and then iterate over the map and look for the element whose frequency is greater than or equal to n by 2, then simply return it. The third approach is very important and optimized, which works by taking 2 variables, votes and candidate. Now let's understand each approach step by step. So first approach is all by sorting the array. Let's say we have an array that contains 2, 2, 1, 1, 2, 2. Now we have to calculate the element which is coming more than or equal to half of the length of array. So we first sort the array, then our sorted array contains 1, 1, 2, 2, 2, 2, 2. Now you can see that the middle element, which is 2, is always the majority element because any element that comes more than n by 2 times after sorting will always be in the middle. And the time complexity for this approach is big O of log n, and space complexity is constant. So here is code, you can see it. Now let's talk about hashmap solution whose time and space complexity is big O of n, because here we are using extra space for storing elements. Here we iterate over the array and increment its frequency in the map, and looking for if its frequency gets greater than n by 2, and if it is, then we simply return the element. Now let's talk about the most optimal approach, which is based on Boyer-Moore algorithm whose time complexity is big O of n and constant space complexity. The intuition behind Moore's voting algorithm is based on the fact that if there is a majority element in an array, it will always remain in the lead, even after encountering other elements. So this algorithm works on the fact that if an element occurs more than n by 2 times, it means that the remaining elements other than this would definitely be less than n by 2. So let us check the steps. First, we initialize 2 variables, votes and candidate, and set it to 0. Then traverse through the array using for loop. Now if votes equals to 0, then choose the candidate equal to array I and make votes equals to 1. Else if the current element is the same as the candidate, increment votes. Otherwise, decrement votes. Explanation for the steps is: the algorithm starts by assuming the first element as the majority candidate and sets the count to 1. As it iterates through the array, it compares each element with the candidate. If the current element matches the candidate, it suggests that it reinforces the majority element because it appears again. Therefore, the count is incremented by 1. If the current element is different from the candidate, it suggests that there might be an equal number of occurrences of the majority element and other elements, therefore, the count is decremented by 1. Note that decrementing the count doesn't change the fact that the majority element occurs more than n by 2 times. If the count becomes 0, it means that the current candidate is no longer a potential majority element. In this case, a new candidate is chosen from the remaining elements. The algorithm continues this process until it has traversed the entire array. The final value of the candidate variable will hold the majority element. Let's go through the code. So first we initialized candidate variable and set it to 0, similar for votes. Then iterating over the array and checking our conditions. And finally return the candidate.